Welcome back. The Apache Flink is a distributed stream processing system that works on master-slave fashion. The master serves a manager node, whereas slave service and the work nodes. The master receives the request from the client and assigns it to slave nodes for further processing. The slave nodes work on those assigned tasks and update to the master node. Okay. The Flink runtime consists of two types of processes, a job manager and one or more task manager. About job manager, the job manager demos running on the master node of the cluster and work as a coordinator in the Flink system. It receives the program code from the client system and assign that task to slave nodes for further processing. About a task manager, the task manager demos running on the slave nodes of the cluster and perform the actual operation in the Flink system. It receives the command from the job master or job manager and performs the required action. Okay. There are some key components in the Flink we have to clarify. Let's introduce them by details. The client. The client is the client is not part of the runtime program execution, but it used to appropriate and send a data flow to the job manager. After that, the client can disconnect detach the model and stay connected to receive progress reports attached to the model. In generally, we can provide a D or without D option when submit Flink job and console command. We have been used the option when submit the Flink job by console command and previous section right. Job manager. The job manager provides the comps of functions, as you can see and here. It transfers the job graph into execution graph for eventually execution, data flow graph. It provides the schedule to schedule the tasks. It provided the checkpoint coordinator to adjust the checkpointing of each task, including the checkpointing start and end times. It communicates with the task manager through the actor system. Also, it provides the recover metadata used to read the data from the metadata while recovering from the fault. Okay. In the job manager, it has the following components. Resource manager. The resource manager is responsible for resource allocation, deallocation, and provisioning in a Flink cluster. It manages task slots, which are the unit of the resource scheduling in the Flink cluster. And dispatcher. The dispatcher provides a REST interface to submit Flink application for execution and starts a new job master for each submitted job. Please pay attention. Here is the job master, not job manager. Okay. It also runs the Flink web UI to provide information about job executions. Actually, we have been used browser access the job manager web UI. Actually, it is the dispatcher. Also, the M option during submit Flink job by console command is a point to the dispatcher too. Job master. A job master is responsible for managing the execution of the single job graph. Multiple jobs can run simultaneously a Flink cluster. Each having its own job master. The task managers, also called workers, execute the task of the data flow, buffering, and exchange the data streams. There must always be at least one task manager and the Flink cluster. The smallest unit of the resource scheduling in a task manager is a task slot, as you can see at here. The number of the task slots in a task manager indicates the number of concurrently processing times. Please note that the multiple operators may execute in a same task slot. In the task manager, it has the following components, such as the memory management, actor system, and network manager. Okay, this is a high-level introduction to the Flink runtime architecture and internal components, and we will learn more about their responsibilities and details in the following lectures. All right, see you next lecture.